Okay, I welcome you to the week 2 online facilitation of PHY 205. That is the course title, Introduction to Space Physics. Last week, I gave you an self-assessment exercise. I say you should differentiate between comets and asteroids, and I hope you have done that. Today, we'll be looking at satellite systems. Satellite systems. And the main contents includes fundamentals of satellite systems, basic characteristics of satellites, improved space platforms and launching of satellites. We'll also look at transponder. What is transponder? Spacecraft and repeater, spacecraft communications, and finally, spacecraft antennas. The objectives of this unit, at the end of this unit, you should be able to explain the fundamentals of satellite systems, and you should be able to list the basic characteristics of satellites. And also you should be able to define transponder. Then you should be able to discuss the principle of spacecraft and repeater. Then lastly, you should also be able to list and explain the various types of spacecraft antennas. Okay, so let's go into the introduction. Satellite systems have evolved into an everyday commonplace thing. Nearly all television coverage travels by satellite. Today, reaching directly to the home from space, in our homes, we have televisions, and through the decoders, we're able to connect to various channels. We're able to connect to different channels in the television as a purpose of communication. In the age of wideband fiber optic cables and the internet, satellites still serve the basic telecommunication needs of a majority of countries around the world. For example, domestic satellites have greatly improved the quality of service of the public telephone system and brought nations more tightly together. That's why the world is presently described as a global village, because you can be here and communicate with other people far away from you. And that is basically by the help of satellites. Okay? So what are the fundamentals of satellite systems? What are the fundamentals of satellite systems? Satellite communications, no longer a marvel, as I said, to humanity. Satellites are adapting to developments in multimedia information and personal communication with the cost of one-way or two-way earth stations, now within the reach of many potential users. Okay, a unique benefit has developed in the area of emergency preparedness and response, mostly used by the federal emergency agencies, where in the case of flooding, where in the case of earthquakes and other that requires fast response, can easily communicate. But what are the basic characteristics of satellites? What are the basic characteristics of satellites? One, a communication satellite is a microwave. It's a microwave repeater station that permits two or more users with appropriate earth stations to deliver or exchange information in various forms. Okay, now a satellite in a geostationary Earth orbit, GEO. Please take note of that because we always use that acronym GEO. Geostationary Earth orbit revolves around the Earth in the plane of the equator, okay, once in 24 hours, maintaining the precise synchronization within the Earth's rotation, okay? Let me take that again. A satellite in a geostationary Earth orbit, GEO, revolves around the Earth in the plane of the equator once in 24 hours, maintaining precise synchronization with the Earth's rotation, okay? Now, there are two other classes of 24 hours orbits. That is the geosynchronous orbit and the highly elliptical synchronous orbit. Take note of that. I said there are two other classes of 24-hour orbits. One is what? Geosynchronous orbit, and the other is highly elliptical synchronous orbit. Both of them involve satellites that appear to be stationary, okay, relative to a fixed point on the Earth, okay? Now, a given geosatellite, don't forget what I said, geo, which is geostationary Earth orbit, okay? Satellite has a coverage region illustrated by the shaded oval within which the Earth stations and can communicate with and be linked by the satellite. Okay, we can see the figure there. It's a system of three geostationary communication satellites. We can see three satellites on the orbit around the Earth, which provides nearly worldwide coverage. Okay. Also, just like this is a satellite operated by Sky Perfect JSAT and built by Boeing 707. Okay, by Boeing. Okay, so you can see the satellite moving around the Earth, sending signals to the Earth, to the stations. Okay. Then let's look at transponder. What is a transponder? The term itself is a contraction of two words, transmitter and responder. Okay, that is where we get the word transponder. It's from transmitter and responder. Okay, which originally referring to a single frequency repeating device found on aircraft. Okay, the purpose of the aircraft transponder is to add the identification of the aircraft and actively enhance the power to be reflected back to the radar transmitter. Are we together? The satellite communication industry has long used the term transponder in reference to a defined RF channel of communication within the communication payload. Okay, so the transponder then is a combination of elements within the payload. Take note of that. The transponder then is a combination of elements within the payload. A satellite transponder is entirely different because it is more of a transparent microwave relay channel. Okay. Also taking into account the need to translate the frequency from the uplink range to the downlink range. So please, I want you to take note of the uplink range and the downlink range. Check that. That's part of the things to do. Check that, the meaning of uplink range and downlink range. Okay, so the spacecraft and repeater. Okay, what is a spacecraft? A spacecraft is the actual piece of hardware that is launched into the orbit to become an artificial satellite for the purpose of providing a radio repeater station. Let me take that again. A spacecraft is the actual piece of hardware that is launched into orbit to become an artificial satellite for the purpose of providing a radio repeater station. Okay, the physical elements that a communication spacecraft comprises can be divided into two major sections. One, the communications payload, or just the payload. Okay, then containing the actual radio communications equipment used for reception and transmission of radio signals, and the spacecraft bus, referred to as the bus, which provides the supporting vehicle to house and operate the payload. Okay, so please understand that. The emphasis in this chapter is on the requirements and specification of the payload and how the general types of hardware designs can meet those equipments. Okay, so let's look at spacecraft communications. The design, by now, the definition of spacecraft, the definition of transponder, you also know the definition of repeater. So now let's look at spacecraft communications. The design, manufacture, and operation of a communication satellite are no simple matter, complicated by the fact that it must survive the rigors of launch and deployment in orbit, followed by many years of satisfactory operation without physical intervention by human beings. In layperson's terms, we assume that a certified repair person cannot travel to orbit to repair or reconfigure a satellite. That is certainly the case for geosatellites, but it is not economically feasible, even for large constellation of LEO satellites. Okay, it is critical that the payload and the bus, okay, work hand in hand to establish a highly efficient radio repeater on a stable space platform. Okay, now let's also look at space antennas, spacecraft antennas. Okay, spacecraft antennas. You understand how spacecraft communication takes place? Now let's look at the antennas, spacecraft antennas. There are different antennas. Let's look at the first one, horn antennas. Okay, horn antennas. If I ask you to explain this, you should be able to do that. Pyramidal horn, in which the end of the waveguide is flared outward in the shape of a pyramid or a cone. The dimensions of the opening are in direct proportion to the wavelength and are dictated by the shaping of the far field antenna. You understand? So the pyramid horn is well suited to linear polarized systems because of the natural straightness of extending rectangular waveguide. The standard waveguide mode of propagation is maintained, resulting in what? In a symmetrical main lobe pattern and little or no cross polarization component. In contrast, the conical horn flares from either a circular or square waveguide. In the latter case, there must be a square to circular transition into a circular aperture. Okay, this type of horn is best suited to dual or CP, while the LP performance of the rectangular horn is superior. Okay, so we can see the figure there is showing a common type of horn antenna called the pyramidal horn. Okay, so let's look at reflector antennas. We first look at what? The horn antennas. Let's look at the reflector antennas. The simplest and most effective antenna system for a conventional FSS and BSS satellite employs reflectors and feed system, the feeder. Okay, now the feed system normally consists of one or more horn type radiators in the transmit mode. Microwave energy enters the feed horn from a waveguide that carries the output of the repeater. Okay. The feed horn radiates microwave energy from the focus of the parabolic reflector into space in the direction of the reflector or sub-reflector, as the case may be. Okay. Two typical antenna geometries using parabolic reflectors are shown. We can see in the diagram, they are we can see the prime focus fed parabolic reflector sending signals towards the earth. Then we can see the direction with which the offset focus fed parabolic reflector antenna is sending signal towards the earth. Okay. So now, this is your self-assessment exercise. I expect you to do it just like the one you did before. This one, it says, explain the basic characteristics of satellites. Explain the basic characteristic of what? Satellites. So in conclusion, you have learned in this unit that the communication satellite is a microwave repeater station that permits two or more users with appropriate earth station to deliver or exchange information in various forms. We also have learned that even in the age of wideband fiber optic cables and the internet, satellites still serve the basic telecommunication needs of a majority of countries around the world and individuals also, okay? So in summary, you have learned that all telecommunication coverage travels by satellite. As I said, in your homes, offices, through satellites, we are able to get coverage of our televisions. The same thing with our phones, mobile phones, cell phones, and the rest. Okay. Also, a satellite in a geostationary Earth orbit, that's the GEO, revolves around the Earth in the plane of the equator once in 24 hours, maintaining precise synchronization with the Earth's rotation. Okay. Then there are two other classes of 24 hours orbits. The first one is geosynchronous orbit and the what? Highly elliptical synchronous orbit. Please make sure you take notes of that. The purpose of the aircraft response transponder is to add the identification of the aircraft and actively enhance the power to be reflected back to the radar transmitter, which I believe you remember we discussed that. Now also, I've learned that a spacecraft is the actual piece of hardware that is launched into orbit to become an artificial satellite for the purpose of providing a radio repeater station. Got it. Thank you. So we'll look at satellite networks. We'll now look at satellite networks. Introduction. Let's introduce this. The majority of satellite operations depend on the reliable transfer of telemetry and command data between the actual Earth stations that are in direct contact with the orbiting satellite and the control of spacecraft subsystems, where the full range of technical and management functions are performed. Okay. Those links, which can employ both terrestrial and satellite network, usually satisfy the data throughout and quality of service, QoS, objectives of the overall satellite control systems. Now, the objectives of this unit, at the end of this unit, you should be able to understand the various satellite orbits configurations. Okay, you should also be able to explain the architecture of satellite networks and list and explain 3 generic forms of satellite connectivity. And also you should be able to define connectivity. Okay. For satellite configurations, having already introduced the concept of geo and non-geo satellites, we can now examine some of the technical particulars. Behavior of a satellite in Earth orbit follows Kepler's laws of planetary motion. I hope you have not forgotten that. The 3 Kepler's laws of planetary motion. Okay, for the purpose of emphasis, let's try to state them again. The first Newton's law of motion states that, the first Kepler's law of planetary motion states that the orbit of each satellite is an ellipse with the Earth centered at one focus. Let me take it again. The orbit of each satellite is an ellipse with the Earth centered at one focus. The second Kepler's law of planetary motion states that what? The line joining the satellite and the center of the Earth sweeps out equal areas in equal times. The area is bounded by the arc segment of the orbit and 2 lines that extend from the center of the Earth. Okay, and the third Kepler's law of planetary motion states that the square of the period of a satellite is proportional to the cube of its mean distance from the center of the Earth. That relationship is plotted in figure 9. If you check the material, the course material, you'll see that. And to give an idea of the relationship between the altitude and orbital period. Okay. Now, 3 most popular orbits for communication satellites are LEO, L-E-O, MEO, and GEO. LEO, MEO, and GEO. Okay. The respective altitude ranges are 500 kilometer to 100 kilometer. That is for LEO. And for MEO, it's 5,000 kilometer to 12,000 kilometer. And for GEO, geostationary Earth orbit, is 36,000 kilometers. Okay. Only one orbit per altitude is illustrated, even though there is a requirement for multiple orbits for LEO and MEO satellites to provide continuous service. So we can see the figure there. We can see LEO, we can see MEO, you can see GEO showing in the diagram. Satellite network architectures. As I say, you ought to understand this. I have to understand this very well. Okay. Any communication satellite performs the function of a microwave relay in a telecommunications network. Are we together? The most basic type of relay is the bent pipe style of satellite, which does not alter the nature of the transmission between the Earth stations. Let me take that again. I said the most basic type of relay is the bent type style of satellite, which does not alter the nature of the transmission between earth stations. Okay. Now, the earth stations in this case must organize their transmissions to efficiently use the satellite repeater resources and to allow the various points on the ground, okay, to transfer or exchange the required information that then determines the basic network structure for the particular application, okay? And the general features of satellite networks. A property with which a satellite network provides via links between users is called connectivity. What did I say? Connectivity is the property which a satellite network provides via links between users. Are we together? So make sure you note that word connectivity, because I'll ask you what connectivity is all about. The three generic forms of connectivity are: one, point to point. Okay. The second one is point to multi-point. And the third one is multi-point interactive. What did I say? Three generic forms of connectivity are point to point, point to multi-point, and multi-point interactive. Now, this will be your self-assessment exercise. First one is to define the term connectivity. What I just gave you now, so you should define that. You should be able to define that. Wherever we are, even if you are sleeping, they wake you up, you should be able to define the term connectivity. You should also be able to list and explain the three generic forms of connectivity. Okay, in conclusion, you have learned in this unit the various satellite orbit configurations, satellite network architectures, and general features of satellite networks. Okay, in summary also, you have also learned the behavior of a satellite in Earth orbit follows. You have also learned that satellite in Earth orbit follows what? Kepler's laws of planetary motion. You have also learned that lower Earth orbit, that's LEO, lower Earth orbit systems employ satellites at altitude ranging from 500 to 1,000 kilometers. You have also learned that the altitude of a medium Earth orbit, that's MEO, medium Earth orbit, is around 10,000 kilometers, a period of about 6 hours. Now, you also learned that the most basic type of relay is the band type style of satellite, which does not alter the nature of the transmissions between Earth stations. Okay. Then you've also learned the property which a satellite network provides via links between users is called connectivity. And don't forget, I asked you to do that in your self-assessment exercise. And the three generic forms of connectivity are point to point, point to multi-point, and multi-point interactive. Okay, so that will be okay for today. So I believe you have learned a lot and you'll be able to go through the course material. Make sure you do all your self-assessment exercise and also answer all the questions in your tutor mark assignments, which I will grade you all with time. Okay, so see you next week. With time, we also organize a special session for questions and answers. Okay, so see you next week. Thank you.